Hi everyone. In this video, we are going to discuss about LTI discrete time system. We already know that the abbreviation of LTI is linear time invariant system. So the input to this system, the LTI system, is discrete time signal, right? So the system is known as linear time invariant with discrete time system. In this LTI DTS system, we are going to see the topic convolution sum. The meaning of convolution is we are going to multiply the value of input signal, discrete input signal, and the impulse response of the system to get the output y of n, right? So let us assume a system. This is an LTI system. Where the input is x of n and the output is y of n, and the impulse response is given by h of n. This is the impulse response of the system. So this is the discrete time input and this is the impulse response of the system, and y of n is the corresponding output. So this can be written as y of n is equal to x of n convolution of h of n, right? So this is the formula for convolution sum. So the signal which we are using in this x of n is discrete signal, so it can be abbreviated or it can be expanded with the help of summation symbol. So y of n can be, the same formula can be written as y of n is equal to summation n is equal to minus infinity to plus infinity x of n convolution of h of n minus m, where n minus m denotes the delay signal, either it is advanced or delay, right? So this is the impulse response. H of n minus 1 is the impulse response, right? So we are going to substitute the values of n from 0 to infinity or minus infinity to infinity based on the input samples, right? So this is the formula for convolution sum, right? So to solve this convolution sum, basically there are three different methods. First method is graphical method, the second method is tabular method, and the third method is matrix method. Among these three methods, the easiest method is the matrix method. This is the easiest method among the rest two methods. So this is the easiest method, right? So we will solve a problem related to matrix method, right? So problem number 1, perform convolution of LTI system with input and impulse response of x of n is equal to 1, 1, 1, 1 and h of n is equal to 2, 2, right? So solution, here they have given the value of input, discrete input signal, that is x of n is equal to 1, 1, 1, 1. So there are 4 samples in the given x of n, and they are given h of n, and they are given h of n is equal to, there are 2 samples, 2, 2, right? So these are the samples, right? And they have not mentioned the 0th sample, or they have not given the value from where the sample is starting. So we can assume that in the given input signal, we can assume that the values starts from the first sample, and which is n is equal to 0. So this is the value of x of 0 where n is equal to 0, right? So this is n is equal to 0, and this is n is equal to 1, and this is n is equal to 2, and this sample is n is equal to 3. So these are the corresponding samples magnitude values, right? So if they have mentioned any arrow mark, if they have mentioned any kind of 0th sample value, then we have to consider from there, right? But in this question, they have not given any kind of arrow mark in either in x of n or h of n. So we can directly assume the first sample as our 0th sample, that is n is equal to 0, right? So to solve this, first we need to find the length of n, that is we need to find the length of n. For that, we know the formula y of n is equal to, we know that the formula for convolution, y of n is equal to x of n convolution h of n, right? So this is the corresponding value we are going to find. We need to find the value of y of n, right? This is what they have asked, right? Perform convolution. So we need to find the value of y of n, and this is the formula. So to solve this, first we need to find the length of y of n. We need to find the number of samples in y of n, in the output, right? Y of n. So for that we need to find the length of x of n and h of n. Now find the look at x of n. Here there are 1, 2, 3, 4. There are 4 samples. So x of n is equal to 4, and h of n, look at h of n here 2, 2. So the total number of samples is 2, right? This first sample and the second sample. So there are 2 samples, and here there are 4 samples. So it is 4. So let us assume x of n is equal to, which is n1 is equal to 4, and h of n is equal to n2 is equal to 2. Number of samples equal to 2. So the formula to find y of n is equal to n1 plus n2 minus 1. This is the general formula. So substitute the number of length of values or number of samples in this formula. So n1 is equal to 4 plus n2 is equal to 2 minus 1. So which is equal to, so 4 plus 2 6 minus 1, which is equal to 6 minus 1 5. So y of n, so output y of n, we will get y of n with 5 samples, right? So y of n will have, output y of n will have 5 samples when we convolute the given x of n and h of n, right? So right. So this is the first step, right? Now next we need to, in next step we need to, let me write the value of x of n is equal to 1, 1, 1, 1, and h of n is equal to 2, 2, right? So to convolute this, I need to draw a table, right, where the column represents x of n and the row value represents h of n, right? So the value of h of n is 2 and 2, 2, and the value of x of n is 1, 1, 1 and 1, right? So now after writing this, I need to write x of n in this vertical manner, and x of n is row wise or in horizontal manner, right? So I'm going to multiply these two values, right? 1 into 2, similarly 1 into row into column, right? Or column into row, like matrix multiplication, right? So 1 into 2, when I multiply this 1 and 2, I will get 2 here. So I write 2 here. Similarly 1 into 2, this 2, I will get 2 here, right? Next, similarly the second value of x of n is multiplied with the h of n, first value, right? So 1 into 2 again here. Then next, for x of n is multiplied with second value of h of n, 1 into 2 here, right? Similarly I need to multiply these values. I will get this as the result, right? After this, I need to separate the diagonal elements or diagonal values from the given. So this is my diagonal value, and this is my second diagonal value, and this is my third diagonal value, and this is my fourth diagonal value, right? So these are the dotted lines denotes the diagonal values, right? Now I need to add the diagonal values to get the value of y of n. So y of n can be written as now the first sample of y of n can be written as, this is 2 here, right? So only I have 2 in this diagonal. So 2 comma, now look at here, in this diagonal I have 2 values, 2 samples. So here 1, 2 is available, here 1, 2 is available. So 2 plus 2, I need to add these diagonal values first, right, to get the sample for y of n, right? So 2 plus 2, I will get 4, right? So I need to add these values. Similarly, I need to add this diagonal, right? So 2 plus 2, I will get 4. Next, here 2 plus 2, I will get 4. And last, I will have only one value at the last diagonal, so I can write it as 2, right? So this is my output y of n when I convolute x of n and h of n, right? So 2, 4, 4, 4, 2, right? In this, I need to mark my first sample of discrete signal, right? So in the question, they have not mentioned any sample, any starting sample, right? So I can directly write my first sample 2 as n is equal to 0. So this is my n is equal to 0 and this is n is equal to 1, similarly, etc., etc., right? So it is only enough to mention the first sample alone. So I am drawing an arrow mark here and mentioning it as n is equal to 0. So my sample starts from here. So this is n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, and this is n is equal to 4. So totally the length of y of n is 1, 2, 3, 4, 5. So totally there are 5 samples in the output y of n, right? So which we have found already, that is y of n, the length of y of n is 5, right? So we have got 5 samples. So this is the corresponding convolutional sum of given sequence x of n and h of n, right?